Hello there. We are going to talk about logic gates. And to do so, we're going to actually work with something that's a little bit simpler. It's a computer that I built this a couple years ago that I still use to this day. It's very helpful. It's my umbrella light computer. This is my umbrella light. And what it does is it goes on when I need to use an umbrella. And when it's off, I don't need to use an umbrella. So I won't show you how it works just yet, but no umbrella, umbrella. So I know it's a little dim here, but you can kind of see the light going on. So it's a very sophisticated computer. Let me show you what it looks like a little better. Here we go. So what we have here is a typical desk lamp, all right, with a wire that runs down the back that you would normally plug into the wall. But what I did is I snipped that wire and fed it into this simple light switch box. It's a 2-gang out the box. There's no circuits or anything in there. See, the wire comes in and then comes back out. But while it's in there, it is tied into these 2 light switches. And the reason that I did that was to demonstrate how simple logic gates work. Now they work at a really tiny, in a really tiny amount of space using only electricity. So you're not physically switching switches up and down, but they use what are called transistors, which are basically teeny tiny little light switches that are flicked on and off by an electrical signal rather than a finger. So let me explain how this works a little bit. I have 2 switches here. This first switch determines whether there is rain or there's no rain on the day. The second switch is if I'm going out or if I'm staying in. So, for example, on a day where there's no rain and I'm staying in, both switches are down and no umbrella. Now, I'm looking outside today and it does look like it's rainy, so I'll flip that switch up, but I'm staying inside. I'm in here for right now, so I don't need to worry about going out. No umbrella. Now, conversely, if I had another day where I was going out, but it was not raining, I might switch that up, and I don't need an umbrella. But if I have both of these switches up, so if it's rainy and I'm going out, I don't know if you can tell, that light went on. I'll just turn it back. You can see it's flicking on. That light went on. I need an umbrella. Now, you're probably looking at it and saying, that's not a computer. That's just wires going through 2 light switches in a way that seem to make some logical sense here. Exactly. But that's all computers. That's all logic gates. Logic gates are just tiny little electrical circuits that behave exactly the way this one does. This is set up to be what is called an OR logic gate. Or sorry, not an OR logic gate, an AND logic gate, meaning that I only want power going to my output if input A and input B are true. So if both of these are true, I get power going out. So it seems like this system is thinking. It's not thinking. It's just putting electricity through a series of switches that happen to align with a logical process, a logical decision. If it's raining and I'm going out, I need an umbrella. All right. So that's a brief introduction to just kind of what makes a logic gate a logic gate. You're going to see about more of it in this module, and hopefully it makes a little bit more sense as you go along. All right, bye now.